Welcome to Notes 21 and exponential functions. The key in that title is exactly like what it sounds from what we did in lesson 20. It's all about the exponent, okay? So a function that has an exponent. By the end of class, you will know the form for an exponential function, and you'll be able to evaluate an exponential function as well. So what do these things look like? Gone is y equals mx plus b. Oh, so sad. And now I introduce to you y equals a times b to the x power. And you're like, what? We got to learn something new? Yes, but for some of you, this is exciting because all we've done is linear equations up until this point, and we're like mid-January. We're halfway through the year, and so now something fresh, something new. And we're going to find that it's actually got some old things in it, like the a value being the y-intercept. So yes, that hasn't changed from when it was the b in the y equals mx plus b form. So still knowing where it crosses the y-axis, but the b value is the multiplying factor. So no longer are we adding, now we are multiplying. And the x is the exponent. All right, so there is a y, there is an x, but the x is up top and not on the side. So let's get further into this with the first example. Now, so if you fold the paper after starting with an original thickness of 0.01, then each time you saw it double. So it's multiplying it by 2. So 0 folds, it's its original 0, 1. 1 fold, we double that and we make it 0.02. 2 folds, and now we double it again. We're multiplying by 2 twice, and now it's 0.04. 3 folds, 3 twos, and now we're up to a thickness of 800. So it is increasing. It is getting thicker every single time. Now, we folded this thing like 7 times. Does that mean whenever I do these problems, I'm going to have to write out 7 twos? No, because we got a better way. And that better way is with an exponent. So let me show you. The formula for these are going to be in that original form. Instead of y, I'm going to use t. And the reason why I'm using t is for thickness. Okay, I got a reason. I always put the initial value, the y-intercept first. Okay, piece of paper started at 0.01. Now, what was I doing? I was doubling it. So I'm multiplying it by 2. Now, how many times do you multiply by 2? 1 fold, 1 2. 2 folds, 2 twos. 3 folds, 3 twos. So the number of folds is the exponent. That doesn't quite make sense. Stay with me. If I folded the paper 10 times, how thick would it be? Well, the thickness of the paper would be 0.01 times 2 to the 10th power, because we would multiply by 2 10 times, and who wants to write 2 10 times? Nobody. So take the shortcut, use the exponent of 10. Now, how do you figure these out? Well, we've got a calculator, so why don't we go ahead and use it, right? So pull up your calculator, and if you don't have one of these, take your cell phone out, turn it sideways, and it will give you every single scientific function that you need, or look online for a graphing calculator. Now we're going to type this in exactly as we see it. 0.01, start with that, parenthesis 2, close parenthesis, raise it on up to the 10th power. I use that little up arrow, right? Once you've done that, the calculator takes care of the rest. 10.24 centimeters. It's pretty good, right? So that piece of paper, when folded 10 times, will end up being 10.24 centimeters thick. Exponential function in the form of f of x. Of course, as soon as I stand up, this goes all haywire. In the form of f of x equaling 8 times 2 to the x power. So what does that all mean? Well, don't be freaked out by f of x. Just remember that that's the x value. We did talk about this a little bit in the beginning of the year. Now, we're trying to find the y value knowing the input, knowing the x value. So I take the a and the 2, and I keep that the same, but instead of x, I use the x value of -1. Now here's the reason why practice 20 was so important, because if you don't know what the value of 2 to the negative first is, then you can't do this, right? So let's remember that this is currently a fraction, 2 over 1. Negative exponent says, I'm in the wrong part of the fraction. Get me out of here. So this is going to change to 1 over 2 to the first. And now I've made that exponent positive, which really what I've done is made it 1/2. So 8 times 1/2 is simply 4. And this is f to the -1, where this is the x value and this is the y value. And you're like, great, Mr. Petrie, big deal, right? Big whoop. What did we just do? What we've done is come up with a point. So if I come over here to the y and x axis, I know that that point is at -1, so 1 to the left and up a little bit, because this is 130, so don't go up too much, but right about there is one of the points of this function. So you're eventually going to see what this looks like. Next up is the 0 value. Now, 0 is a really important number, and we'll see why in a second. So this is the x value. I put it in for the exponent because that's where x is, and I evaluate. What did we say about anything to the 0 power? 2 to the 0? It's worth 1. Now let me answer the question. How come we're not multiplying by 8 first? Order of operations, right? We always do exponents first. So we've got 8 to the first, which means 8 times 1 is 8. The math of this is never going to be hard, and if it is, you've always got a calculator, okay? So I bring down that f of 0. What does that all mean? It means the x value is 0, y value is 8. So let's graph it, right? So 0 left to right, up 8. Oh yeah, remember what 8 was? 8 was the y-intercept, where it crosses the y-axis. So because when x is 0, that gives you the y-intercept, this formula, this equation, will tell you the y-intercept when we know that x is 0. Okay? Keeping it going here. So f of 4, x value is now 4. So I substitute 4 in for x. And I just keep doing this based on the number they tell me to use. Now, I could use my calculator, but let's remember that 2 to the 4th has to be done first. 2 times 2 times 2 times 2, 4 of them there is really 16. Okay? And 8 times 16 is 128. I'll just kind of be your calculator for today. So what have we done? We have found that f of 4 is 128. Remember, that is y, this is x. I go back over here. My x-axis right here, that's a 4. My y goes all the way up to 130, and I got to plot 128. Oops, didn't mean that. So it's going to be right about there, okay? So when I go to graph this, this is your first one, you'll get the hang of it, but do not make a straight line. Do not grab a ruler and start connecting these. You just have a nice freehand curve that goes up as it goes to the right. So more of like a banana shape than a straight line, okay? How'd you like that? Your first exponential function. And it's equal to 54 times 1/3 to the x power. So let's go ahead and evaluate when the x value is 0. So I replace every x I see with 0. I keep the 54, I keep the 1/3, but the new number up top is 0, all right, just x. Anything to the 0 power, you know what? So anything to the 0 power is worth 1, and so 54 times 1 is simply 54. I read it all fancy, but that's just x and that's just y, and I can put this on the graph. Now, this right here just means where we're going to graph. So on the x-axis, I'm going to go from -2 to 4, and on the y-axis, I'm going to start down at -10 and then go all the way up to 100. And you're like, 100? Do we really need that? Yes, you actually really do need that. So the first point that I know about is 0 left or right. It's up 54, which is about halfway. So there's our first point, the one we just found out. Let's do another one. Next time, x value is 2. Same function. This time, 2 in for x. 54 times 1/3. we do that to the second power. Now, we could use our calculator to show you this, so why not? So in your calculator, you're going to press 54, parenthesis, divide by pressing the division key, or to make the fraction that it is, press the division key, close up your parenthesis, and then raise it up to the second power. Okay? Press enter, and voila, it is 6. Magically, the calculator tells us that it's 6. So G2 equals 6. Well, that's X, that's Y, that's a point on the graph. So 2 is halfway between 0 and 4, and 6 is obviously much lower, so something like that. Now, for your second attempt, let's see if it's better than the first. You're just going to draw a curved line that approaches the x-axis but never goes below, all right? In most cases, these will not go below the x-axis, and we'll get into that in a little bit, okay? Nothing in the chat, so I keep going. Why is this exponential function decreasing while the other one was increasing? Well, this one we were doubling, right? We were multiplying it by 2, and in this one we're multiplying by 1/3. What's the same as multiplying by 1/3? Dividing by 3, right? So because that b value was less than 1, it caused it to decrease. So let's take a good look at this. It's going to increase if the b value is greater than 1. So anytime you multiply by a number bigger than 1, obviously it makes it increase or makes it larger. But if we multiply by a b value that is between 0 and 1, so again, that's a compound inequality that only means between 0 and 1, it is going to decrease. All right. So now let's take a look at these functions and just kind of pick them apart. So we know that there's an a value and a b value, right? There's two numbers in each of these. The a, it's alphabetical order, comes first. The b comes second. What does that tell us? It tells us that the 8 is the y-intercept, okay? Maybe I should write the first one out. So the 8 is the y-intercept, and the 2/3, because it's less than 1, is a decreasing function. Okay? It's going down. Let's see if I can make some room for this next one. Now again, let's kind of pick it apart here. First number, second number. A value, 125. B value, 1.5. What does that tell us? It tells us that the 125 is the y-intercept. Okay? The b value, let's think about it. Is it bigger than 1 or less than 1? Yeah, it's bigger than 1, right? So it is increasing. So can we write an exponential equation from a table? I know that you've done this in 8th grade for a linear function, but can you do it for that type of function? Well, there's one thing that stays the same. Whenever we have 0, that's the a value. And you know how they kind of look like an a value, right? 0, a, they look similar. So the 10 is the y-intercept. 0, 10, right? When we're going to go graph this, it's going to go up 10, 0, 10. Now, the b value, how in the world would you find that? Remember when you made the little triangles underneath the boxes and you tried to see how much it was going up by? Similar, but this time it's not going up by the same amount, it's being multiplied by the same amount. So 10 times something gives you 30. 3. 30 times something gives you 90. 3. 90 times something gives you 270. And if you're just looking at the 9 times 27, yes, that's 3. And 27 times 81 is 3. So that is going to be the same. It's going to be consistent. So I can't say constant, but it's going to be consistent. So the b value is 3. And are you ready for how easy this goes together? Y equals a value, parentheses, b value, x is an exponent. Did you hear that? X is an exponent. All right. So one more time, practicing your new equation. Start kind of low, continue to rise, and then shoot off to the moon. You've just drawn yourself an exponential equation. Okay?